Hello and welcome to another programming session. And today we're going to be making my own cello. This is not a competitor cello, it's just my own version. So this is the Lib Cello GitHub right over here in the soldering video right over here. So to start on making my own cello. By the way, if I get anything that I think could be added to cello, I will email Daniel Holden, but I don't know what's gonna happen. So I'm just gonna begin by creating a basic STDO. Hello world. I was just doing a test before this, by the way, so let me create a one.sh. You have to give it permissions. Let's run it. Okay, so I'm gonna create a lib.h because I don't know what the name is. It's gonna be so here's our lib.sh. I'm just gonna include some of our libraries. And for in out, we need to define a no size key. No size key over here, because size key is already defined in the STDO. Yeah, that doesn't exist, obviously. So now what we're gonna do is we're gonna begin. The way I want to begin with such a complex project is by creating a generic, basically a type of that will I'll search up generic in C over here to get a basic generic. This is roughly how it looks like, by the way. So I'm gonna go, well, obviously we need to accept the argument, which is G. And I can add my own objects to this, which I will do. I'll change this to a lowercase string. I will add a character to this list. This will just be void times if it's default, so that we always get a type. I kind of just want to put string. That would be more simpler. And then I think we could just, well, there's multiple ways we could do this. One is by not having a string type at all. Two is by like defining the char times as a string. Three is by creating a struct. Now, what happens over here in cello? This is something that I don't really like about it. I should probably open this with my GitHub, but I'm not gonna do that. So anyways, one thing that I don't like about cello is the way that the string is initialized. It doesn't have a length. I think there's no point of doing that. You might as well just made a type def of a char times, because then you could easily cast it. I don't think there's any point of doing it like this. And obviously, yeah, you could get the length from just the char times, right? Wouldn't that be a more efficient strategy? So I think I'll just actually, I would usually think of doing a struct, but I guess I could do this. New strategy. Right. And now I think we should do like some kind of type check for macros. Right? So we need to get the T. Obviously, we need to get the type and the expected type. So if StuCMP type expected type, we can't just do equals because then we'll be comparing the pointers to the direct objects in relative memory, which would not be valid. So we compare these. The types have to be string. This is a very messed up technique. We should check if type and expected type are strings in the first place, but I'm not going to do that. So T type, I'm just going to put that. So if it is the same, well, no, I'm going to do if it's not the same, actually. So if it's not equal to 0, then I will assert. Something like that. Actually, rather than including stdio, I want to include nested and see what will happen. I want to use nested in our program itself. That's what I'm meaning here. So I will write then to1 stringlen expected. So expected, what did we expect? We expected type. And then we'll do got T type. Okay, this is a very messed up technique, but let me check if it works. Let me give a 5. T type is string, and then I'll just put character right over here. We don't have a StuCMP. Let me man StuCMP. This man page over here will get it, and rather than putting the library, we're just gonna put this. Because we don't have a StuCMP in our string library. But we don't want to include the entire library, right? We have 3 errors. Oh, I forgot our library, or epic library, am I right? Has that. And we could use the print W of our library. But we're not gonna, because it doesn't, yeah. So we expected character. Got string. Yeah. We expected a character. We expected, but we got a string. Now we don't know what this type, but we do. I don't want to create a comprehensive function that'll convert it all to characters, because what happens if it's not in the list? What would we do? And I'm gonna use a type of, let's get a type of this. Expected character got string. Type of this. Expected character got in. This should be more. Yeah. Right. So now, roughly 9 minutes in, we have a basic type checking system. We could just call this expect. Right. We could just put this at the start of a function like expect. Right. Arguments basically. So let's create a function. We already get basic like print W. Print W, right? And high, we could already do that. Let's just use something that's in here. Print choice. Okay, let me just print choice high. Expect yeah, to get a high. Print choice high. And over here we do want to give 1 and a new line. Expected character got int. And yeah, we could do online. Int to string. String into string. Let's actually do on file string len file. On main dots on this 1, and then string int to string six. So is there anything like a call? No, just line. 2. Expected character got int on C, and then I could just go to F. Cool. So we could already expect stuff. Actually, let's do an underscore expect. And then I'll expect is over here. Expect our T, the type of T, and the expected type. So just so that we have both of them, just in case. You have a void times, and then you have the real type over here. Right. So now we don't need this over here. Just automatically do that. And if it's an int, it'll just pass. So now let's create print. I mean, I don't think we need to get a print, right? We already have print choice and that stuff. In print. I think we need all of these to be strings, right? So you do something like this. Yeah. It's actually pretty cool. That how does it do this? What? Whatever way it uses, that's actually kind of cool. Does it do some kind of define and print? No. out of the box, it just does that. That's just success. It's actually epic. All we need is some kind of caster type, I guess, and then that type could cast to whatever type it needs to be. So if I'm gonna do an underscore cast here too. I'm gonna do underscore cast just cause, yeah. If type of T is equal to type, we won't do anything. But else if okay, I just want to do something like that, and else if the CMP of the type is a string. If CMP type of T is equal to a int, then T will be equal to string into string, and then whatever number we have over here. Wait, so we'll put it here. Well, if the type is a char, we'll have string char to string. Easy. I'm not gonna do I'm not gonna do anything else. So if it's an int, we don't have an int string to int. Here we could just do cast it to an int. I mean, I think for now that's all we need, right? So now let's see if we could have an int a equals 5, and we cast the a to the type of a string. Now we expect a as a string. Isn't a as wait, so type of a int, yeah. So I'm over here should have printf. Yeah, we get it. So now let's just see what it expands to. I'm gonna try to read this. If it's a char, if it's an int, what is there not? Okay, I can't read this. Yeah. If it skips over that. Is it has to be like should there be a thing here? No. How come it won't work? What if we just had it like this, nice and short? Then we do the string into string A. I think we change all, give it T type. Hello, so let me continue working. I changed my mind about the entire cast thing. I'm just gonna remove that. We'll only have expect. So anyways, we can create a, something basic. Now, what I wanna do is I want to add a basic new command. Right. Then you will get the type and something else. And what this will do is look at the type underscore new, and it will give it the vargs. So I think that's so. Now let's create a new int, and we'll give it the number 5. And now over here we will have our this new will doesn't give us what expands to. Will this make it show me? No. Right. So now we're gonna just create an int new, which has the int a, and we'll just make it print hi. So now we can run the sh. Yeah, that's what we want. Doesn't print us high. Let's just print it. Is this how you put it as a string? Yeah. Should I just give it a type 1? I think we need to do the paste, right? Okay, I have no idea how to do this. What does it expand to? How come it's not giving us that? Giving me that. New int 5. Wait, it gave us that before. Wait. Yeah, this also works. Finished. So now why don't we print f the type of this? It'll immediately segfault. Wait, give us int. Oh, that's because it's what it puts over here. Now, usually, I think when you're doing that, you wouldn't give anything, and so I think that's yeah, it should work. Right, we just initialize a new int. And we get the type of it. Now we can't do short times, so this is when it becomes helpful to have a string. Wait, actually, I'm gonna do a string and string. I'm gonna take string, actually. It's just more helpful to have it like that. Also, since this corresponds with that, and we messed up to have, yeah. It just, yeah, for those reasons. And then string new is string A. And we can get that it's string. Okay. So now I want to assist the user when they're creating their own structures, right? There's multiple ways I could do that. One is by creating a macro that is a struct. A struct macro. A macro called struct. Another way is by doing all this and then use a macro that says init. Stuff like that. Now something that would seem logical is to just call this macro inside of here. But the thing is, for that I need code outside of the struct too. I can't really do that. Then so I think it would be easier if you defined a macro called struct. And then we also let the user do it the normal way too, right? So the first thing, we would have the name. Q, we would have the struct and then the name. Obviously we would do that automatically. So we would have struct. We would have a basic struct over here. And I want to give its name. Its name should be hello. Over here. And I want to make it as similar to the normal C syntax. To make it that similar, should we use this? So we just do we do stuff like that. Pretty basic stuff. Too few arguments. Oh. So we could do stuff like that. But the problem, wait, actually, that would be pretty fair, right? So, then I could give it a functions. We could do that, yeah. Well, we should probably give it a function macro. So, and then the macro will take the name, the args, and the exec. Wait, so then we could put the function called hello. Is it possible to just do that? Okay, I think that gives too much personal stuff that the user could do. So I think I'm gonna skip on that. So then we'll just have that. And then the functions. But wait. Well, guess we could make it do something like that. And then just have the functions. Yeah, we have two little arguments. Would it be okay if I did this again? Yeah, I think you should just do that, I guess. What's the problem here? Well, I'll give it the exec. Field main declared as a function. So or not check. Oh, okay. That would work, yeah, so I could just do over here. I think we should probably do that actually. That means it would only work with one function. Okay, first, before all of this, we need to make this, we need to create an init function. So I think this should be the init, right? And I think the init function should be right here. No, that wouldn't be fair. That would work. I just want to wrap it for it. Like, so over here in the init, I could take in the function. I'm not gonna like oversimplify it too much. We have a function and function pointer. Over here in the function, what you're gonna have, we're also gonna have the return. The init function will not have a return. I don't think that, yeah. So, we'll just have it be like, well, I guess we will. It'll be the type. Wait. But we already have the type. So yeah, we don't need it. I'll just put name over here. And then it'll be the same way over here. There's this new. I think it'll be name. I'll just go new. The args. Then the exec. Okay, okay, that reminds me, either way, we should probably put that here. When we're doing new, here we have type, and then hashtag, I'm just gonna use. How come it's not working here? Oh wait, I need to put that in the init function. So I'm just going to do this. This is what it simplifies as. Hello, what? So name. What if we did hashtag? Surrounded by hashtags. Then it wouldn't work, because the entire thing would expand. Let's just put it as a struct then, I guess. And now we have a problem with there. So let's just define a merge, A, B, A, B. Then we merge name and underscore new. Okay, what would happen if we just put underscore new? Oh wait, okay, wait, I get the problem. Hello new. Oh, this is an init function. So name doesn't really matter. Okay, I guess we could just do new then. That way, init underscore new is a function now. Oh, we don't want it as we must use struct to refer to it. Okay, now I guess I could just type def and put name. Both sides over here, type def Lib Cello, init new. We put our init code here. I think what's most important is that maybe you don't expect it. Maybe just put it as a code. So this is our init function. Our code is just here. Unterminated so could I see what the student should do? Because it throws an error, it doesn't give me the code. Come on, man. Unterminated function like macro invocation. Oh. Why do we do that? Okay. Anyways, let's see the code that it generates. Hello, init new, and then we do that, yeah. What we should definitely do over here is that we should create a name self is equal to malloc size of name, and then we do return self. Oh, there's actually something left. We need to add an argument for that, but we can't do that. So does that mean we should add the but I don't, yeah. So we have to create it. But I don't know how to do that. So how do I get that? I need to do struct name. But I can't do that. You know, it's fine. I'll just give it a struct. And then so now over here, that's it. After that, we should have another argument, which is okay, so a name in okay, next argument could be variables, but we can't do that. How about we just do the struct definition, which is a macro that takes it the args. So the struct definition will all go over here. So now if we need to initialize a variable, do that right over here. Initialize a variable. No, I'm ultimately going to say that I don't need any args for my initialization function. What this means is that I could now create underscore new doesn't exist. Oh, why did I do that? Okay. So wait, we put name underscore new. Init underscore we need the struct. This is where the struct is useful again. Now it puts it as void times because we don't have a type for it right in our program. I wish there was a way to do that. Actually, you could override the generic that's here, and then we could add a hello. Now obviously that one work. Need that. So now let's do a run.sh, and we do get the hello, which is the type. We have to override it. I wish you didn't have to do that, but we are forced to. Anyways, it's actually kind of cool that you could do something like this. You could create a init and then the struct definition, which has the stuff. We could simplify it even further, but I'm gonna get really confused if we simplify it further. So I think we just keep it like this. However, I will add some utilities, such as this, like, so we get what we return. Then we do times name. Args. You don't need an exec for this. So now we do have a function pointer. You could say it returns an int, its name is a, and it's args. Just a. And now we get that transferred into real time as our actual function gets transferred. Kind of epic if you ask me. And then we could, yeah, let's add a function definition. We already have the function for that, right? So we could give let name all the args exec. So we're gonna say example here could initialize a function pointer to returns an int, its name is a, and its args empty over here. Then we could create a function with the function definition. Get name args exec. Wait, we get all those. Oh yeah, so we do have to put that in. I'm gonna just do that so it's easier to read. No, so I could just call it func. So now here comes the simplicity of it. It's actually so simple to read, yet it gives the information off. The function pointer over here, and this is the function. One thing it doesn't do, however, is set the self dot func to the func. That's something you need to do yourself. Okay, wait, what? We do give its func. So how is it saying undeclared? Oh, at that time it's not there. So that means that should put it up. Actually, put the functions first before that, and we get it actually that simple. We give self.func equals func. And we could make it even simpler if we just did, I wish init function wasn't already taken. Let's call that new function. And then we have a new init function. So, init function will just take in the name and we'll say self.name equals name. So now we'll just init function func. That's telling basically I have a func that's being used in our program. It's basically just specifying that we will have some sort of func that is inside of this program. This is a very weird version over here, but this is a new function, a struct definition, and this is a function. The thing is, what happens if you have to get more functions? So that's why I'm just gonna put VA args. So the only thing that you can do past this is just more functions. And that would work. Well, I mean, it wouldn't work in real life because we have more function than one function. Wait, what did I just see? Okay. This is actually the magic of what we're doing. Now, sadly, this type of that I created won't detect every single thing, right? Every single, if you create a new object, it won't be able to detect it. Anyways, is there anything else that I want to inherit? Arrays, but we do have with us our famous, not famous, my bad, epic, I guess, array library. Now the thing that's amazing about this is that you don't have to include anything with it. It just, yeah. And with this new array type, you get this. Now, is there any errors? It's that we expect a new. Is that because we already define string here as short times? Okay. So that means that we already precisely have it. Yeah, so we just remove that. Now, we have our epic array library. We just do an our new. But because we're using this array library, it means that we can't use create our own array type. I think an array is something so low level that you shouldn't really have it as a class. So I guess we're just gonna have a new. Wait, that is the format of our stuff. So doesn't that mean that we could? Okay, that's actually epic. I planned this. I didn't plan this. If I don't stop. I didn't plan this at all, but it's actually epic that we do get a chance to. Have that. Now we should actually probably recognize a ton of these as stuff. But hi. Oh yeah, it needs to be valid type. But anyways, we need to recognize these. We're gonna recognize all of these as arrays. So our string, everything that we support, a double, a float. Everything that comes out of the bag with our array library. A long, a unsigned long, and a unsigned it. So these are a ton of array types that are just added now. So now, if we do this, So does it return it as a new? Yes, malloc in mallocs. So does that mean that it'll work if we just add times this to all of this? No. It's because this gives a built-in malloc, right? So why don't we just turn this all into an other type? Isn't this a malloc? So yeah. Of viz. If it's anything, I'll just do that. So here we have our library automatically included. Easy, just as easy as that. And about a pointer, what is this? Why did they redefine pointers? Doesn't like what? Anyways, for the function they have their own stuff. Yeah, that's fair. I guess you could have a function inside of a thing, and then you could do call. Well, it depends on what the function looks like. But the definition for the function looks like, if it's just that, you might as well just type def. Like, I don't get why this Daniel Holden doesn't do type defs. It would necessarily remove the need to have a ton of stuff that they have to deal with. Anyhow, for our strings, we just use the string library. Nothing fancy. I would usually have like some, if I had the this idea, then I would be able to do dot, and I would be able to overload functions into that. But because I'm using char times, I won't. Because the problem with that is that it becomes really unreadable to be readable. Like, you could do dot new with the string now, but now every time you have to knit, you have to do a. And I think that looks really annoying that you have to. It's really annoying that you have to do that. Also, where is my, what is this? Okay. Very happy face-to-face version. So now, I think we don't even need an stdio for some parts, because we could just use print chars. Okay, yeah, that's the problem. We don't know if we're including size T or not. So I think we just remove it out of there. If we don't have size T's, we just put it there, right? So we have an array of ints, right? Let's just define a no size T. I wish stdio or something like that. Does it have anything like that, like stdio dot h code defines stdio-h. So I think no size T over here. Or no. I'm gonna do if not defined stdio-h, if there's no FTDO is not included. Wait. It should be so yeah, now oh, so is it if not defined then? Yeah. And then if I remove it, yeah. So it works either way. Anyways, if we allow ourselves to have new epic functions, structs I meant. So now we don't have something that can compete with Cello, but we do have something that's pretty cool. Especially since Cello has a garbage collector, its own garbage collector. Like, can you believe that? Can you believe that we're not gonna have a garbage collector? Because if you have any garbage, then you're gonna have to deal with it. Like, okay. So now some file is something that we could create a struct for, and we will, right? So now just to show how cool the structs is, I'm gonna see if I could build a func entirely using this struct. Just to show that it's good, it's a working system. Because it's already complete, because it has, if you need anything, you already have the struct definition. So even if there's something that we can't handle, you have the struct definition. Go do it yourself. So yes, this is a new function. We'll obviously we'll file, and the arguments that it will take to create a new file is the name and the permissions. For the permissions, I think we're gonna do what is loadable. I'm pretty sure it depends, right? String int could be 8, draw type is 4. And then if we defined it as a, either way, this is gonna be confined to like a pointer. It's gonna be put back to a pointer, but I'm just gonna I think I'll put permissions, like an int. So cute. File can read. Okay, can I just like ask generate random pointers? I'm using Python. I know how to, so I'm just going to print rand. For some reason I trust Python randomization. Math, is it? Math.rand function in Python. Oh, it's also sudo. Rand.randrange. Random in Python. Oh, it's random.randrange. 11. Okay, so now I need a much larger range. 793. Okay. Well, kind of want it actually more in the large scale, probably beginning in 5,000. So 9390 doesn't really sound like a suitable number to me, but anyhow, and we're ending these numbers with the exact number that it starts to give uniqueness. To show, yeah. We can read, we can write, can append. We have this. So, here you go, here's a file. Take in the permissions, and what we do inside of the function, instead of the thing, we won't init any functions yet, because we don't have any. I'm just gonna do that. So, now, we should probably do some self dot here. We should make it have the name and the permissions. Now about the in out, a file in out requires it's custom. That's epic. It's not type def though, so we will have to do the old struct file. So a file over here will be file open. I should do show times type then, if it's easier, right? If I already have something that'll directly. So I just wasted that time for nothing. Sounds like something I'll do. So this is roughly what we have. I believe file open gives us just file, not the file types, not the pointer to file. Good. So now we should be able to create a new file. Arguments to file is hello, and then the permissions. Let's read the description of the video. Wouldn't that be epic? So what's the problem here? Struct file is undefined. I'm pretty sure it comes by default. So sounds like a skill. I'm joking. So over here. Okay. Wouldn't that work, right? That should work. Oh, that was yours. So now we need to define some functions. So what we do? We should obviously have a read. Now I'm gonna look at what we have here. What does a read do? It takes in the int. So we actually need to get the length. So let me do that first, actually. Int. I think since we have our own struct, I think every function should take. Since we went all the way this far, we need we just need a way that every function takes in first. But that would make it have to be. So I think I should just create a struct function. Our own struct. Right. Built for structs. And before the arguments, we have we should, okay, I guess we have to do struct for this too. Okay, I don't want to, that just makes stuff annoying, right? Am I the only one with this opinion? Honestly, I should just be using a new function. Yeah. So obviously in a function pointer, now we need a struct function pointer so that we can automatically initialize struct index. So now we need to give it a special, we need to use a special struct file pointer. We have to give it a file, and we need to what we're gonna do with it is it's gonna take nothing. It just returns an int. Int. Our name is v is length. Let's just say seek. And then no arguments. So now we need to get this a struct function. We need to give this struct function gets the return value, name, args, and then the exec, which is just code. So over here, what we do is all we have to do is file get length. We just return the file get length of a self. That's precisely all we need to do. This actually feels so epic. And this should compile. Expected identifier. That gives us actually a new problem. So do we have to put void in these now? Well, that would, yeah, so I think guess we're just gonna have to use a normal function pointer. Problem with that is now we do have to explicitly, it doesn't give us the magic of just using self. Wait, actually, if we defined a struct args, so we have A and then the rest, right? The reason I did that, well, I didn't need to do that. So now we need our own struct args. And now we get another what is that? Expected identifier? Oh wait, that just makes, okay, wait. I get what I was thinking about. Struct that. Let me just not pass anything. Wait, why'd I go through all that trouble if I could just not pass anything? So let me just cancel that out. Oh yeah, so we need to get self that file. and a parameter list without what is that? Struct function pointer. I don't see how the problem is in the function pointer. Like, do you have to give it the name that it's self? Okay, must use struct tag to refer to, and that's what I'm doing. Hello? Hey, wait, okay. Either way, I type defed it right here. So I have to deal with that here. Parameter list without types. Okay, 1 hour and 9 minutes in. A parameter list without types is only allowed in a function definition. Parameter list without types. Aren't we in a function definition? So that means, I guess, it looks like it's yielding it from here. So int seek file self. So does it want us over here to say that its name is self? So what? Oh, because we're midway, we need that. So in here, we belong to struct file. That makes sense. So now, let's print f. The file dot seek. Let's see if we seek. I forgot about that. How come we can't do that? Do we not have the permissions? Do we have to sudo dot out just to what? Sudo. Okay, yeah. They're just segfaults. Cool. Let me just print f high. It was destined to segfault. Oh, it's segfaulted even before that. All the way over here. So should we just like cast it automatically to our type file? Oh, so now it goes here. No. Probably expects us to return self. No. Hello? How is this working? So name is restrict. Okay. Type is R. Does a self.file exist? Yes, it's valid memory. And if we get length, this is what we're doing over here. I actually created this. This makes me feel kind of happy. Okay, what if I just don't seek it? It works. The problem is with seek. So wait, what does this read then? If it's like, if you could seek while just doing size, file.pose plus equals size. Okay. So in all fair rights, I'm going to create another function which is meant to read. It's called read. Takes in a buffer to read into and the int size. So over here we can put that in. We want a buffer. We want int size. And I'm here in an area. So file self. Expected parameter declarator. So I'm so confused. I'm just gonna guess. So what the problem is over here it expects, this is the function pointers problem, which is pretty easy to fix. So it still says expected parameter declarator. It's a struct function problem. Oh. I think in all fair rights, if there's no arguments, we call it a function pointer, and then we give in the self. Now it gives it too many arguments in invocation of, so giving it too many arguments according to it. The args file self. So, what does the function need? Good. Oh yeah, I just realized it that quickly. There's conflicting types for read. Yes, that makes sense. Wait. Never mind, that does not make sense. We must use struct tag. Yeah, because whenever we're within the thing, we have to use the struct tag. So, where was that, 70? And we have conflicting types for read in the struct function. Oh yeah, so I think whenever we're doing any kind of function, we give it an undo line before it. Then I paste it. So what we got wrong that entire time was that we didn't init the functions. So we need to init the function seek. We need to also init the function read. Use of undeclared identifier seek. Okay, yeah, I should make it understand this. Should I just paste it over there? So the size is 228, and let me see if I can read this. So takes the file, the buffer, and the size. And one. So let me just a read here it has this, and we skipped it. Read void times buffer int size return. Why'd we do that? Oh, we didn't give it a new definition. So we should. Why we return? I don't think we need to return anything. Actually, we return a size t here, so I guess we'll just read the file with our self.file void times an int, which is the buffer size. And that doesn't return anything even. We need to get the A that it gives. Let me just see if I can seek. Let me just seek now. Yeah. So we get 228. So now, file.read. We read the file, which is yeah, and then the buffer, the size, we're just gonna do file seek. and then we give the buffer that is a so it returns nothing, but there is defined power within this. Okay. So when we open, we do take in an I, and we change based on that. So over here, let's just give it as this. 100 is the length of a buffer. Dang. In simple words. So now, we need to get the length, which is apparently 228. So why don't we just seek the file? Get that. So we seek the file, we get some data. But I think the seeking of the file itself, get length, is itself changing. Yeah, so I think what we have to do is, we're moving the cursor with us. The position, it's moving with us, because every time we read a character, we're adding the size to the position. So here, I think the simplest way to fix it okay, this is just reading one character. I think the simplest way to fix it is by saying that we want to get the position, and we'll minus the count. So now a buffer moved to the start. But this doesn't really work. I don't know. Okay, I'm just gonna put that for now. I'll fix it later. It's kind of epic that after 1 hour we have something basic. We even proved that our library works by creating our own struct inside of the program itself using this. So they have their own list. Anyways, not we, they. It's not ours. It's not mine. So this is what's in our table over here. We have a vdata, k type, and v type. Yeah, I guess that key and value. And why is there space? Catalog table step. Okay. Is that the amount of space? That's the amount of space we have because they're using an array. C-style array. That's actually, okay. It's all clicking in. So over here we have a custom array type that's not even fully done, actually. We need more functions inside of this, but I consider this a win for the file system. This has already been quite long. 1 hour, 18 minutes. So over here we have our file that's here. I don't know nobody's really gonna use C in the future days. So I guess I just like created this for nothing, but it's in hopes that if I transfer this, if I create some high level stuff like AI in this, I could make my own dreams inside of here. Because I know in reality I should be coding in Python right now to get ready for what they should usually teach us, right? Like I should usually just like know Python. Why am I doing C? I just do it because it's my passion. Like I could also turn this into high level stuff and have like AI into this if I make this complex enough, which is probably not gonna happen. But you could do AI in C without my library itself. I'm just trying to make it easier to do stuff such as AI in C. Right? So there's an entire string library. Okay, yeah, they have because there's no such thing as operator overloading in C, they created it using the strings. That's something that's actually like pretty cool. I don't really have exceptions. Okay, so anyway, to clear some doubt, if you're wondering why these videos are so long, you're probably watching the stream version. I'm gonna create a short version too. Anyways, here's some stuff we have. They have in their library. Daniel Holden as, I think I got that right. So now we have some exceptions. Okay, I think we should have some help so that you could just call a help function, right? So I think we should have a help type just here, and that'll just do type underscore help. What if that printed that? Right, so now I could have int help and help equals an integer. So I think I put this with here, so all the types that is supported here could be put here. String in long integer in array of. Okay, at this rate I'm just copying like the type of. I'll add more, don't worry. But I should probably duplicate, but so just do anything help. Anything. You should convert it to a type to get more information. Okay, I should probably so now we can just, we should also be able to get a file now. file. And also we didn't put help for a lot of these. So let's see now if I have a problem with file. Oh, we should probably indicate the type. Oh, why do you do that? What? Oh. A long help. Array of unsigned integers. I don't think that's file. A file. I'll add more info later, don't worry. So anyways, we can print out the file over here. So I'm gonna actually add the types. So wait, you should probably put that with our structure. That would have made it so much easier. So I think we should add like a help function now. Like right over here. When we have a help function as a second argument, and necessarily what it does is it just over here we put a name underscore help, and then you put help. So hopefully this will turn out well. In a test over here. So wait, what does this expand to? Char name help a file. So the problem is that it still gives us a name help. So I was supposed to do that to get it to. Oh wait, so this one works, but this one does the one that we don't. Okay, no, it does. It works. So now, rather than having an individual file help over here, we don't even need that. And when we run it in the help file, we should still get the same a file, right? And we can change it to, yeah, we happens over there. It doesn't process it correctly here. I think we should just do the command disable arrow squiggles so that it just ignores that completely. So I'm actually pretty happy with how we got to this stage right now on just 100 lines of code. Could you do that in 100 lines of code? And also, since we can't like define any like equal signs, I would define at least like this so that you could do like something like 5 is 5. But the thing is, if we're calling a function, then that just does not look good for the average human eye, right? So we probably gonna do something like is over here with the two arguments, self and then next like and then we would have to get the type of the thing. So actually this type of, and then we'll merge it with like underscore add, and then we have the self and then the that's what we would do. But I don't think we have enough time to do that. I actually like the way this has gone so far with our custom structs. Basic classes. You have basic classes over here. Now, what I think you could in the future do, over here, we could somehow try finding a way that we don't have to do that. Or the init functions either. I have like a hope that we won't need that in the future, but I can't really think of a direct way to avoid that using macros, right? So something else we could do is to make this look a bit more compact per se. We could move the functions into struct definition and then sort them out later, which I do find a direct way to do, but I don't want to do that yet, you know. So that it looks like everything's instead of a struct rather than this. It's kind of a weird feel, right? A problem I could find with that though is never mind. Let's actually not do that because that would be kind of complicated to get which ones are functions and this commas here. So I think we'll just keep them outside, I guess. Now something else that would be kind of cool, I'm not sure if I could do this, is if we could move these out, like all these out, and not have a struct definition, because then it would look like they're outside of the functions, because the functions will access them, right? Just looks cleaner that way, right? It would be kind of helpful if the help could be at the end, but I don't think of a direct way to. I can't think of a direct way to do that too. So, like if we wanted this help to be optional, I can't really think of a way that I could necessarily do that. I will try my best to think of ways to do that and stuff. So, with all of this we can expect, I think something else we will do in the future is possibly add a cast function that looks like this. And then we'll just put the new type here. So either like this int I don't think we can really do something like this, because first of all, if I define that as a macro, it would override like function calls because they also have this. So I think we're gonna be left with the option to do something like this. We have a cast int I, and well, it would cast whatever I is to an integer, right? So we can assume that this is, and then like for a later test, you could create this and then expect it as an int, right? That would be a pretty cool idea. So anyways, these are a ton of new ideas to possibly add to our lib function. I see a bright future to this by adding like a ton of new libraries such as exceptions and stuff, arrays, like formal arrays, I guess. Like our array library is more for normal C, right? We're trying to build like an extension on top of C. So you might use a few array libraries, but not the same way we're doing with the string library. We don't really accept it that much as part of our lib, right? We just have it inside of our code. So this is my own cello. I will add my GitHub once I post this out, but I'm not going to do that right now. So okay, something else I could see happening in the future is possibly finding a way other than generics that could always give you something. Because for now, if we define a new struct and we want to get the type of it, we can't really necessarily do that. And that's kind of disappointing in a sense. Now, something else we could do is we could use the default type of, but mark it around in hashtags. I don't think that would work because type of is not a positive macro. I don't even know how it does its thing. I'm pretty sure you can see that right here. Let me just put this over here into a res. And I think at the end you will just see, yeah, it doesn't automatically simplify it to a, because it's a complex like type of operation necessarily. I think that's roughly in the assembly time it'll see if it can get anything, and it'll use hints. So in the preparser time it could possibly be getting like hints about the type. So now we're just like chatting about stuff we could add now. So this is a basic file created entirely using our own struct library, which proves that we have something new, and it's Turing complete with the already existing structs, as you can see, because it has a struct definition and it has even a new function. So it's like has more features on top of the normal struct, but it doesn't have the same syntax. It has a messed up syntax. So we will try to fix the syntax of structs possibly. And a way we could do that is by, I think something that we could do really in the future, I don't even know if we can do this, is something like this. We will need a func to say that's a struct function, and then we could do something as simple as this. Now maybe you could just do it in the function and like put it like this, or maybe you could have it separate. I think we should put it in the function, because otherwise if there's a comma anywhere in this code, it'll just get recognized as another argument. Right, so we should probably do it inside of there. I think something that would be cool about this is yeah, if we're doing that, we might as well not need that, and we would find it ourselves. But I don't think I could really see that happening. So I think we might have to like wrap around the function around this case. So maybe just say it's part of file, and then like put all of this, and it'll just do it for you. That would be something that I would look forward to necessarily, but I don't know at this rate. So you might be seeing this in the short version, so you would probably not even understand what I'm saying right now, because it would be sped up 16 times. You wouldn't even hear it probably. Yeah, you couldn't even hear a second of this, because I'm going to turn the audio off in the short version. So yeah, you heard me if I said it enough times. Like basically that we will have a short version of this, because I'm trying to work towards creating more short end content so that more people will watch it necessarily. So I will like make these videos extra sped up and show basically me creating a high level library. So yeah, I guess at this point I will extend it longer. Okay, So let's think of things next to do. I was just searching up Coding Daily. This is some cool stuff in the type.c. I found out that type of is actually a function, not a macro, and it does something pretty cool with headers to find out type. I really need to find out how this works so that we could take inspiration from it, because again, it's not us that is helping Daniel Holden. It's Daniel Holden that's helping us. Basically, just think of it like that. So, what I think we could work on that's different from cello is that rather than having like in cello, you have to do like a var a equals cello to have it supported. Well, some stuff supported like the help and stuff like that. I kind of like that, but again, I would rather have this that does everything automatically for you. If we had some way to like optionally give the help, like we could just say no help. Like I think a way to do that it would be by giving a 0 here, like 0. I don't want it. Yeah. So anyways, we could expect this int over here. I'm just gonna check out the old program that I created. When did sh? And it does do that. If we expect a string, won't work. Yeah, so type checking system is pretty Gucci. And obviously our help file itself, if we do that itself, it'll be so you're telling me the help necessarily the print function that the help put chars returns the amount of numbers printed, so that's why. Yeah, okay. So something that's pretty cool is that when help has to be on its own. This is kind of like a feature inside of itself, right? Because if we need to check it, we don't want to put it out, right? We just want to check, yeah. So I would expect to put it twice because I expect does that twice, and then actually even more times because, yeah. Anyways, pretty cool. So now we have basic type checking inside of macros itself. Inside of the macros itself, just something that I like. However, what it will do is when we're trying to define a macro and we expect it, when we're looking at the process statements, this is some long code that we're gonna have to look into, right? So now I could create some basic macros that we could expect. Now, if we create a new file description, I'm just gonna do this again, because why not, actually? And then, it just feels cool to check stuff up, right? So, I'm just gonna put in this, and then, we need a buffer. I'll just give it 300. We will fix that error that was over there and start eventually. Now let's just print chars for the buffer. The new file. Okay, yes, we do also need to specify that we want to read. Create my own cello. This is my epic stuff. Check it out. This is a good outro, but I'm not going to do that, obviously. So we have a new over here. I really wish we could do something like this. That would actually be so cool. The thing is, could we do that? Because if we were to put something in here, even if it was like we switch to auto around, we have this space, this annoying space, and we can't really do anything about it. So yeah. Now we could also print the seeked version of F. None. Oh yeah, we have to put that above here. I don't like the pointers from our library. Yeah, that's because we have to do string int to string over here. Pretty cool. So, now that we have our own functions, this is looking like C++. Good enough for like a C++ thing, right? Like, doesn't this look like C++ other than the fact that we're passing a function in itself? I wish we could do that, but the thing is, well, we could do like define read and then somehow find a way to get the self. Like, yeah, we can't really. Well, if there was, well, actually, if you could get the like pointer of a function in the function, like without having any external stuff, like say in this function, it takes absolutely nothing. But what if it found its own pointer, right? Because the function pointer is open instead of the struct, not the function itself. We could try to find a way that, well, either way, the way that they're instantiated, then you will be after, or a function would be after. So you could just get like the memory after that, and we could get one function of there. That's there. So probably in the 2 hours 10 minutes roughly, 2 hours 15 minutes. I don't know. I can't see the length of this video while I'm creating it itself. But we do have dreams of a possible cast. So I will create the foundation for a cast over here. Cast type and then T. What is called to do? Well, I guess I'll just do it like this. Right. So we will add casting later. And then function, struct function, new function, function pointer, struct function pointer. Yes, one more thing I would like to add. In a struct, it's annoying that we have to put a struct function pointer and put the function that it belongs to. In all function pointers actually. Okay, let's just do this right now. Like, we need to like put a struct. Well, you know what? I'll just put it like that. We need to find a way to get the struct that the program is currently in. If you could get that, we need to get the struct that we're in to make it easier. So I don't know how we're gonna do that. Like, we could possibly define a macro when it's defined of the current struct and then get it here. So could you, actually the question is, could you define current struct name? This would be kind of messed up, right? Yeah, it won't work. Nice dream. Wait, we could know, cause okay. So that just blew all my dreams. Is there any possible way to check if we're inside of this function? Because if there was, that would change the way that structs work forever in our lib.h. We don't even have a name for it. We should probably decide on one. Like not cello, obviously. I can't think of good names like that myself. I'm not that capable. And yes, we have to do that infamous H the if and def, the the basic check to make sure that we didn't include it twice. Which is what we should actually do. We should actually put in. We should actually define. So at the end of all this, we put an end if. So what's here? We have the address of the stock memory. Yeah. So I think in gcc/help. There'll probably be some kind of warning. Okay, we're back, and for the cast function, we want to do something similar to the we have here. We do so what we want to do, I think we need to do a type of T in U. I think we should do a I think we should have the class that we want to cast to, and then we have a cast from, and the T. And so int cast, for example, with the T, I think we should also give the type of T. Version. So if it's a else, if we're casting from a string, well, actually, do we really, I think if we have something that accepts an int and we pass it like this, it won't actually generate an error. Yeah. Now if we do a try times and give it this, will it generate an error? No. So I think we should do some like checking to make sure it's an actual pointer. Let me see if it would be valid if we did times 5. Well, void times p has to redo that, has to have that, and then it's segfaults. So how do we make sure that this has valid memory? So how to make sure pointer points to valid memory in C. See, I don't want that. Alright, so now if we need to define a cast, we do it right next over here. So let's say we actually did a cast. So obviously the syntax for over here will be the type that we want to cast to and things. So let's say we cast a string to this. Obviously it will turn into file underscore cast. So over here, if the thing is equal to an int, then we will throw an error. We don't have error handling yet, so I'll just do throw an error. If it's a string, we will actually give it. So what we want to do is we want to give it memory. Okay, I think what we do is we turn this all into a ternary. So we do if it does, then 0, throw an error. If it's a string, then over here I'll give a new file with the T, and for the default type, wait, no, oh, okay. So let's do the default type is an R. And about the problem over here, I think a raise, the raise thing, it should, I don't know. Let me just do that. First, let me just define a new struct. It'll be an exception. What? And then the help will be an exception you can raise. The init will be a new function, obviously from the exception class. Init the args will be show times error. Okay, the thing about this is that it's not a macro, so I feel like we should make the entire exception a macro, like maybe let's just get the most so expected identifier, yeah. And then we have incompatible operand types, file and int. New file. So I'm gonna go with the error is necessary. Both of these need to be the same. So I think I'll just do that. So now okay, so this is a condition. And then you have the ternary, right? I will just put another over here. That does seem to work. So now we will also have the exception macro. And what it will do, for now we don't have a good use for it, so for now we'll just okay. So now we can just throw an exception IDK. So is there some kind of error over here? No kind of error in any way. I think we could just close all this. Hello and welcome to another programming session. So we just raised exceptions now. The problem that I had is that I wasn't putting it to SDL. Cause I think I think you could do something like this if you flush the STD out. I think. I don't know. But I don't care at this rate, so. Yeah, and if there's anything we can add, not really sure necessarily. So we can do this. Cast. when you're creating your own structs, you could also do something like this. But I think actually maybe to make it easier for the user, you could like give like a file cast int, and then it automatically generates the file cast. But I'm gonna give the responsibility to the user, to do the casting. I actually don't know what I should do. I feel like no, we should do like a file cast int, for example. So that means, well, we can't generate a define inside of a struct. So I don't know how that would work necessarily. We will add this over here just because it makes it easier, so that if you need help on it, technically it's a struct. Right, so this doesn't have the actual function. So anyways, I want to work on the exceptions. So to work on it, I'm gonna put dash s slash dat d slash d, and then we could have if you get what I'm doing, I'm basically trying to recreate that. Is there C style errors? Make raise a C style exception in C. Raise exception in C. I mean, I think this in a suit, right? But anyhow, we want to get the file. We don't have the call. Wait, actually, let me just see. Yeah, we don't. Let me see if it runs. Get column in C macro. Get row and column. Get row and column in macro C. What? A macro in C. The location of a macro in C. We have file and line, that's all we have. So we should still have the ability to jump to this. You can get it right over here. Yeah. And the arrow, we need to make it red. So we need to do the ASCII color codes table. And get that over here. So let me see if I could. so this is underlined and all that. So we want to remove 1 and 4. Let me create my own error. How do I get this specific code? It actually depends a lot. I think we're gonna do terminal.app because that's the one we're in. So now, if we were giving this color foreground, it's 91. So doing 91 then, right? Yeah, this gives the one that we have in here. Great, if we were to recreate that, we have the same color. And now we will just give the name and get text at line and file in macro. Terminating process with error code -1. So then we'll give 2 lines of space. Yeah, so now when we have a file cast that is invalid, we can move this up. Can do an exception. I think we could just do like an undefined cast error. And we could give it the type expected type T. So I think we'll just throw an exception saying wait, that wouldn't work. That kind of is really rough. Let me just create try we should sprintf cast cast not available for casting of type to A. Undefined cast error. Let me just try this out first. I should say we were trying to put trying to cast an int to a file. In the int is of type 5. thing we checked, I guess. Unexpected expression. As printf string, how is that an unexpected? Expected expression. How come it gives errors like that? Okay, oh wait, that one works first. Cast not available for casting 5 of type int to an file. So weird finding the cast. We don't know what type that is. So I guess we just shouldn't put T then. Object. So now, I'm just gonna type it give undefined. I think whenever we call help, we should do something that gives all of its functions, like maybe in the struct. I mean, that does sound like a feasible idea, right? If we just do like a char times functions, and then we am I right? Wait. Oh yeah, this merges it together, so this is not followed by macro parameter. What? Did I generate wrong? Okay, I guess I'm just gonna do it like that. What does this get turned into? Over here. So, this is kind of weird the way this was made. Like, why are these not getting... Hello? I'll just really... Oh, I get why there's an error in the code. That this is not followed by macro parameter. So does it have to be this? Okay, I think that should work, yeah. So the thing is, if there's any VAARs, wouldn't that look kind of weird? Because the struct function, this actually works. Okay, I think this is ignoring the fact, what if there's another one after this, which is like, I don't know. We put it inside, right? But my question is, at that rate, in the struct macro, we might as well just, cool everything into a big chunky ball. Okay, like, that might have sounded really sus, but like, just, you get what I mean, right? The spacing only gives one. So do you have to put this right here? It's not followed by macro parameter. I think doing that actually merges two things together, right? Like, so obviously what we need to do is put that, yeah, merges together. So does that mean that, like, let's do a grand finale. This is what we get, which is actually kind of cool. Let's see if I can just paste a /n inside of it. Add a new line in macro in C. NL. Just a new line. So we have to do it's not followed by a macro parameter. What? Oh, is that not considered a macro parameter? Okay, so now let's see what this expands as. What? They lied to me. So I'm assuming this is a character, actually. No, it doesn't exist. Oh. We need to define ourselves. Okay, so that actually adds a new line. So if we define that, it still doesn't work. I have no idea what's going on here. I'm just gonna put a tilde between every thing. I think the way it worked earlier by doing, if we did this, expected after top level, I'm really confused. Is this, let me just put this down, basic program, then we do, oh wait, we have to, if we're gonna do that, we have to paste here. Expected identifier. Struct exception. I'm just gonna do it like that then, I guess. So now we can take the file functions. If only you could like put the new line between them, that would actually be so helpful. Now we could split this into multiple functions, and that's what we're gonna do. So we're gonna have a parents count. At the end we'll show the parents. So then we could do very basic. And So now we're going to we can since this is a since this is a show times, we could do something like this. And we now get the next argument. I think, right? So don't we have in a lib, first function is in it technically. I don't think that counts. The first is seek. It counts. The first one it counts is seek. And then you can see over here that we actually did skip over. So using this, we can create the functions array. Yeah. So we could put this into a function. But yeah. I think in the help we could also add this. And then all of these we're gonna have to do this. Help me. What am I doing? So now if we need to get help on the file, rather than getting help, we get a hideous list. Let's just do the print, and then we will okay, well, we now to show like what we, this is the next one, right? So to show what we already went through, we could do like a string. In the string we put everything that's in the type functions. Actually no, we don't even need to read length of characters, n characters in C print F. And the way to do that is just some kind of print n characters of a string. I just saw that. Okay. The precision specifier, that's what it's called. I'm a failure because I don't know that. So now we can get the I. Do that so we can get this is what we need. So okay, we get the entire seek function necessarily. Well, the only problem is we need to I++. So just so that we have the next one. So Yeah, actually we could just do that right before we break. But what if that's yeah, what if there's only one function? So we have to check. Oh wait, why did I do that? Okay, how did I notice that? I should have noticed that immediately. Yeah. And we get the one function. So now we could possibly find a way to convert this into a human readable form, but I'm not gonna do that yet, guys. So actually, okay. So I think we should have like a list, and then every time we complete this loop once, I'm not gonna worry about that for now. That will be some calculations to do later. Okay, yeah. We skip that. So wait. Why does it keep on going forever? It should stop at some point. So wait. Yeah, so we get, how come we only get seek there? So now let's check that out again. They made it way quicker. Okay. This is gonna be some. Okay, we finally got it. So we get seek, then it stops. How come we can only do this once? Oh. Haha. It still keeps on repeating it. Now I'm gonna put the new line. And then, and I was not prepared for that. Yeah. How come I kept on going then? Wait. Oh yeah, so we need to reset the count to 0 each time. Okay. So now we just have the two functions. We need to find a way to split between these functions. So I think we take you know, that wouldn't work. So could we get like some kind of previous I? So we actually get each thing. I think this is actually like a work finished. Once we obviously get these into a correct format. So a file, we need to get more specific with these. We could call it a file that can read, write, or append. Reading or writing W pending A. Then we obviously have to have like two new lines between it. A file that can read, write, or append, read, writing, W, pending A, and the functions are right over here. Now this could be kind of overpowered. What if there's information that we don't want the user to see necessarily? We will think about that by possibly like, I don't know, we'll see what we can do. So yeah, this is gonna be a long video because I'm trying to turn into some short style content either way. So we can have this file that can read, write, or append these are functions and what they do respectively. Now let's see what else we can add. Let's take inspiration from this library over here. So just, yeah. Go over here. You can allocate. We're not gonna get the special ability to allocate using stuff. Now we want to make this lightweight, so we're gonna remove this and see how it really tunes up. So we have one error in help. So stuff is really dependent on these STD. Well, not really, but yeah. So I think we could easily make this code even seem more intuitive if we just did, well, not really intuitive. You know what I mean? It would just seem and be easier this way. So other two stuff, errors in here. This would be like a lot of code to replace. So I could keep at least one thing that requires SUDO. Oh, you know what? If not defined, stdoh. Okay, that has to be wrong. Like what stdoh? This is what it looks like. Why was mine so weird? Okay. We do want to also get the page for sprintf. I shouldn't really be using sprintf. It's really unsafe. But I'm using it. I don't know why. I'm using it because I'm a crazy man. Anyhow. Okay, we do need a file. This is just getting like bigger and bigger. I'm just going to, just that I don't waste any time, I'm just going to define it like this. Must use struct. Yeah, so we can have this entire code. What the world happened to the help function? So, okay, like, is this stuff that's being leaked? It doesn't really look like a data leak. If we removed it from our code, that fixes the problem somehow. So let me just draw a new line between each of these to make it simpler. So we have a large data leak coming over here. So the data leak is bytes. That's not really okay. Should we be doing I don't know if this is correct. What? Okay, how's I the accurate student here? I don't think it is, right? So is it, wait, I minus previous I? Yeah, basically. Wait, but there's something that's annoying me a lot. Is that was there an error? No. Okay, is it the opposite way around? Oh, wait. Did I, swap it around? Wait, so 20 plus 2. Oh, wait, this is why you don't use light. Use printf. Just how unsafe it is. Okay, wait, why are we putting this on top? Shouldn't we do this at the bottom? And then, so is it the other way around then? We just fixed the problem. What? Oh, I minus previous side. So let's just print Char's string into string. What this is 80 characters. Wait, is that $80, 112? So okay, I'm just curious. Does this work or does this not work? It works. Okay. So, $80, 92, 192. How can these do the exact same thing every time? I don't believe this. So the I, how come the I is 80? Oh. So should we just, do this? and then we give it the previous I just to get so should we have I equals previous I. Okay. So this happens before we're writing the data. So why is there one extra? This is why you should always put your I++ here. That's actually, was that the thing that I was missing? Like, did I overcomplicate things? That's a question to ask again. Kind of. Okay, so let me just let me check over here. Oh, I think we need to check previous I. Oh, okay. So that's solved. We can now get the actual functions. How come the new line isn't? Oh wait, no, it is working. I want 2 new lines. Waiting. So now we have 3 hours in. This is gonna be an extra long session. So we can get the help of a file if we are stuck. Like if we need help, we just put that in and it will give us the stuff. Now I think this should also be for like objects, like if you have an int yeah. Yes, and we have a problem here because what about all of these that don't have stuff? Well, I mean, let's just epic editing stream. Okay. So now we can get the types of a lot of basic things. The functions of an exception. It's actually kind of something I'm curious about. Yeah, it's just like this. An exception you can raise. And the functions, and then we have nothing right after that. So okay, we created a basic thing over here. We don't have a table like cello. We don't have a lot of things, and we don't need stdio for this library, which is kind of cool that it's made up using all my libraries that I've built myself. Those use system calls. So like we have a built-in stringlen. We also have the more complex stringlen. I don't get why we don't use this. That's from string. This is just the built-in version because I use it pretty often. Anyways, we can get arguments. Basically, all of this that we've done before, all these 163 lines of code, I don't consider them high level. I consider them a setup for something high level. C is middle level programming language, like because it's not too high level and it's not too low level. That's what I like about it. It's like in the sweet zone. It's not like assembly. It's not like Python. So it's the perfect zone to like develop stuff that can use abstractions or distractions, which is not even a word. Like you could put assembly inside of here and be low level, or you could do something like I'm doing and try to make it your own Python. And we could create a ton of like stuff that would make it similar to cello, like for each. We will do that later on. I actually wonder what the in station is. Okay, I want like a perfect match. Is there a way I could do that? So also, in the for each function, over here, wait, in is probably a comma, so that you get the, so we could get more specific with that, like do this search. I just can't find any searches. Okay, anyways, we want to go to the for each statement. So, we pass the for each in, yeah, so we call for each in, and for var equals x isn't terminal. Yeah, something else we should work on is, well, first, we should have our own like is, but we should have is as a function, so that you can define your own is necessarily. So you could say if blank is equal to blank, we'll have our own procedure, but it will make it feel less C-like if I were to explain really. So now this is our program. Now you could define something. I'm pretty happy with it. You can define something. You have these functions over here. I feel like they should classify function pointers as different things. That just make it better. There's no privates, sadly. I think we could change that soon. Like this possibly. Yeah, you could we could find a way to put it into a global variable, and then we could just define that variable as nothing right after the function is defined. But that wouldn't really work for your own structs. So that would only work if you specified it outright and you had to go through the pain of not only the pain, you just have to put one macro, but still, like, yeah. A dot. We can read, we can do all these stuff. And if we don't like anything, we could throw an exception. Or that could if we cast, wait, what? So what if I just defined SDO? This is why you should include stdio. This is like a to do exception requires fprintf stdio for stdio as of now find a solution. So as I was saying, if we were to try to cast like a new file. Actually, let me just do like this. It's the easiest cast that for some reason it's the easiest cast that I know. It shouldn't really be, because yeah, and file cast does some error. I wonder why. I still wonder why. Oh. I don't really know what to do then. Just give it an empty file, I guess. New file. Why did I do that twice? Okay, why did I do that twice? Alright. So you can get it. If we cast with an unknown, it won't actually throw an error, but it will not like. So let's say I created a new exception. Passing exception to this is types. No, it doesn't. What? Wait. Oh. I'm pretty sure. Wait, we don't have type checking for exceptions? Okay. And we still have if CMP type string equals 0, then like what we're not even it's not even being what's running. Like hello. Okay, it actually returns. Oh wait, yeah. Just it's oh wait, is that okay? None. Yeah. However, if I was to give this, what? Do I need to wrap parentheses around the entire thing too? Okay, I know it works because I've actually tried it before. Oh wait, is there some error? Wait, no. Okay, so we give something, but it doesn't, the f.name doesn't seem so let's just pretend this is a string. Will this make it a pointer? Oh wait, we have to add. This is what we get. Some kind of pointer like this. Okay, so I guess it's just it actually works. So I guess I'll just keep that later. I'll keep that for later. Okay, this is me here. I made some tiny changes. And I realized that in a struct you can't really have a function without arguments because of what I did. Which is and what I did is fabulous. Really amazing. Stupid me. But anyways, I did do some fixing. Did I do fixing really? I don't know. Look at this. Did I do fixing? I don't think so. Okay. So I did an struct function, so that will in the struct function we now put this, and this instantly makes struct functions better, because now this instantly says that we're supporting struct functions more for structs, because this means that the primitive should be struct and the advanced version is a function. So this might look like the special function, but it's actually the basic function, because this is the one that we'll now be using for basic operations in things such as equals, adding. Yes, we're gonna have that for separate steps. So now something that I want to set up later is like some kind of is function. It'll check either if it's a primitive or if it's a struct. If it's a primitive, it'll run some custom function. If it's a struct, it'll just use the function that you created. If you did not create a function, it'll throw an error that you need to create a function while doing an specific operation. And so basically, in the future, you won't be able to say like file if this is a actual file. You can't just do this because you define the well, no, actually wait. If we ever added an is operation to check if the things are equal, you can't do this. You couldn't even do like this if you didn't have an already built-in operation for the struct. It would throw an error saying file.cmp file1 file2 not found. So over here, don't ask me why I have .h here. So one thing that I did also do in the time that I was gone is I changed the fprintf to an sprintf and then piped it to a right. So to do gone. That leaves us with no more to-dos, so I gotta find something. There's a lot of problems in the struct system actually, but I'm not gonna fix them. I'm gonna do that later. And a major change that should happen soon is changing the entire new function, and hence the entire struct like setup, and hence every single struct that we have already, to return a pointer, because that allows them to change it. So now we don't have to do file f is equal to f dot change, and then that'll probably just result in a seg fault, right? So we have to do something with pointers. But anyways, that's the end of the session. I will see you in the next video. And if you're just like doing like the sped up version and you won't hear me, hi, kudos to you. You just watched like my entire life existence, and I don't even know if it was wasted or good. It was probably wasted. Bye.